kids. Today we have, I think, 5 examples, 7, I don't remember. Let's just get started. So we're in section 1.2, and here's example number 1. So it says, do the data in table 1 suggest a linear relationship between the pressure P and the temperature T of gas? Okay, so we have temperature and pressure. So temperature is 40, 45, 55, 70, 80. Over here, we have more complicated numbers. Okay, so all we really need to do is calculate the slope and see if it's the same at different points. So in other words, we're doing the change in P over the change in T. And if we do that, let's just pick, so we'll pick these ones and see how that goes. And so I'm going to call this like P1, P2, T1, T2. We're going to do something like P2 minus P1 over T2 minus T1. If we do that, so we get 1365.8 minus 1385.4 and 40 minus 45. Okay, so if I pull out a calculator, plug this in, get an answer, plug in the bottom, get an answer, we're going to end up with 392. Now, I'm going to test just like a completely different area. I'm going to test here to here and do that again. So I'll just call this P1, P2, T1, T2. We get this when we plug it in. Once again, plug that into a calculator. We end up with the same number. Now you can try another spot. It's always good to try 3 or 4 different spots. I'm not going to go through that though, but we could test these ones, we could test these ones, etc. On this one I feel confident that it's going to come out as 3.92, and since that slope is the same everywhere, or the constant rate of change, we know that this is in fact linear. So we just say they have a linear relationship. Now, example 2. Let's see. So it says, find the equation of the line that goes through 9, 2 and has a slope of negative 2, 3. All right. This will show up a lot once we get into calculus. This formula that I'm going to show you, you've learned it in the past. You may have learned it in like Math 1 or possibly 8th grade, so it may have been a very long time since you've seen this. Maybe we did it as 11th graders, I can't remember right now. But it's this point slope form that looks like this. And this is just x1, this is y1, and then this is our m. And we can just plug that in. And since that's all it asked, it didn't tell us to put it like in slope-intercept form or anything, we can stop here. If it does tell us to put it in slope-intercept form, or y equals mx plus b, all you need to do is distribute here. Which would simplify. We still have our y minus 2 over here. We add 2 onto the other side. equals negative 2/3 x plus 8. Once again, if it doesn't specifically ask you to put it in slope-intercept form, I would just leave it in the form that's in the green box. But just in case you're ever asked to, that's how you would do it. Alright, example 3. Find the equation of line that goes through these 2 points. So this is going to be really similar to the one we just did. We're still going to use our point slope form. The only problem is we're not given m. Now we can choose either one of these points. This one looks easier to me, so I'm going to call this one x1, y1. But we need to calculate the slope. So I'm going to also call this one x2, y2. And if you remember, change in y over change in x is how you find slope. So we're going to say y2 minus y1, x2 minus x1. It's going to give us 4 over 7. And that's our slope. So 4 over 7 goes there. And minus 2. And y minus 1. Once again, you could change this into point slope form or slope intercept form using the method we did in example 2. I'm not going to do that right now. And let's move on to example 4. Okay, this is completing the square. I'll go through completing the square. I do have another video that goes more in depth on it. I'll go through it real quick just because that's what it asks for, and the way the book does it is a little bit different than the way I do it, and the way that if you had 10th grade math with me, I would have taught you a little bit different than the way they're doing it. So I will go through it, but when we get to example 5, they want you to use completing the square to find the minimum value of a function, and I think there's a way easier way to do it, and so I'll show you that as well. But for now, we're going to complete the square on this. And so I'm going to just set this side equal to 0, subtract 3. Okay, we want to divide everything by the leading coefficient, so in this case 4. Okay, now we do the L step. So you divide by 2, and then you square the top and square the bottom. You add this to both sides, so we get x squared minus 3x plus 9 over 4. 9 over 4 minus 3 over 4. Okay. This side, we're going to do the magic step, which is where we take the elbow and do x plus that number. Since it's negative, it's going to show up as a minus. Over here, 9 minus 3, it's going to give us 6 over 4, which is 3 halves. Okay, now we have x minus, I'm just going to rewrite this so it's a little more clear. Now they want us to write this, it looks like they're trying to write it in vertex form. So we need to bring this back over onto this side. And the last thing is we need to have the same leading coefficient. So we come back to the top, look at it, we get a 4. And so we're going to multiply everything by 4. This by 4, this by 4, and this by 4. And so we end up with, so that 4 times 3 is going to be 12. 12 divided by 2 is 6. 0 times that is 0. And we have completed the square. So if you have additional questions on that, we can talk about it in Math Lab, we can talk about it in class. I do have another video on it. You can just search on my channel for completing the square that does a bunch of problems if you want to review that method, but we're going to move on for now. Okay, now this says complete the square and find the minimum value. So we could go through that process and find the minimum value. use a fairly simple equation. X equals negative b over 2a. This is called the axis of symmetry. So what this tells us, if we have a parabola, it tells us the equation of this dotted line, which will tell us either a minimum, or if the parabola is like this, it'll tell us a maximum. Now, in this problem, does it say minimum? Yeah. We know it's going to be a minimum. A couple ways we know that. Since this leading coefficient is a positive number, because there's a positive 1 right here, we know it's a right side up parabola. If this was negative, then it would flip it upside down. And then knowing that it's second degree, it goes down, comes up. Okay? So what we're going to do, we're going to call this A, this B, this C, so similar to when you use the quadratic formula. There's no C in the formula though. And so we're going to plug in negative, negative 4, and 2 times 1. Negative times negative gives us positive. And we simplify, and the x value is 2. So if this was the correct graph, it would be right here. Now I don't know, this one's actually shifted up, so this graph is not correct, but just to kind of illustrate where that is. Now, this tells us the x value, which just tells us where the minimum's at. It doesn't tell us the value of the minimum. So we need to finish this ordered pair and find the y value, and this is going to be the minimum value. So to do that, we go back to like pre-algebra, take this 2, plug it in for all of the x's, we end up with 2 squared minus 4 times 2 plus 9. So that's 4 minus 8 plus 9. It's going to be 4 plus 1. That gives us a 5. Okay, so the minimum value occurs at f of 2, and that minimum value is 5. Okay, that's everything for this video. If you need additional help, please come to Math Lab. Until then, calculator.